Okay, it's recording. Cool. I didn't forget this time, Fletcher.
I appreciate it.
So here we go. So today we're gonna learn about recursion. Recursion is a way of solving problems where before, remember we had like a function and it'll just return a value, like return some type of value for us. Like for example, the sum
Yes.
function. Yeah. Cool. So now recursion is when we have a problem and we allow the function to either return a direct value if it's easy enough to solve, but if it's not easy enough to solve, then it's going to return itself. The function is going to return itself. And I know that's going to sound weird and confusing, but I'll show an example right here. But before I show this example, I want to show what like the context in which we're using it. So we're going to be using it in the context of the Fibonacci sequence. And how many of you guys have heard of the Fibonacci sequence?
No, I thought that was like, I don't know what that is.
Okay. Fibonacci sequence, don't worry, it's like a sequence that appears in nature, but there's a mathematical model to show this sequence. Don't worry, it's not too crazy. Let's just start with the number 0 and then 1, right? And let's say Fibonacci of 0 is 0, Fibonacci of 1 is 1. But then what's Fibonacci of 2? Well, Fibonacci of 2 is going to be, so after 0 and 1, all the next Fibonacci numbers are going to be the sum of the last two before it. So Fibonacci at, the first Fibonacci is 0, the first Fibonacci number is 0. The second Fibonacci number is 1. So let me put some, first Fibonacci number is 0. And then let me put something right here.
Are you showing something? Because we're not.
Yeah. Let me share the screen. Thank you. I thought when it started recording, it was just share the screen. Okay, can you see my screen now?
Yeah.
Okay, cool. So Fibonacci is basically it'll start. Let's say these are the values. Oops, that's way too. And then this is the Fibonacci number, okay? So Fibonacci number of 1 is going to be 0, okay? I'm trying to line them up. Fibonacci number of 1 is going to be 0. Fibonacci for 2 is going to be, the second Fibonacci number is going to be, the value of the second Fibonacci number is going to be 1, okay? The value of the third Fibonacci number, now we can find out the rest of the values from just these two values. So the Fibonacci, for Fibonacci number 3, the value is going to be whatever the sum is of the previous two numbers before it. So what's the sum of the previous numbers before it?
1.
Yep, 0 plus 1 is 1. So Fibonacci of 3 is 1. Okay, so what's going to be Fibonacci of 4?
2.
It's going to be the previous, Fibonacci of 4 is going to be, sum of the previous two numbers before it.
2.
2. Okay, so Fibonacci of 5 is going to be
4. 3.
Nope, 2 plus 1.
Oh.
The previous two numbers before it. So it's going to be 3, right?
Yep.
Fibonacci of 6.
5.
3 plus 2. Yep, these previous two numbers, right? 5. So does everyone see the pattern here?
Yeah. Okay.
Okay, cool. So Fibonacci of 7 is going to be, well, Fibonacci 7 is going to be whatever the sum of the previous, sum of Fibonacci of 6 plus Fibonacci of 5. Well, Fibonacci of 6 is going to be 5. Fibonacci of 5 is going to be 3. The sum of these two? 7, right? And if I were to Google Fibonacci sequence numbers, these are the numbers, right? It goes like this, okay? It's basically some crazy stuff. It eventually gets really big. Let's compare it. Oops. Okay, so what did they have? They had 0, 1, 1, 2, 3, 5, 8. Wait, hold on. Oh yeah, it's not 7. My bad. I didn't do my math right. 5 plus 3 is 8, not 7. Yeah, 8. Sorry about that, guys. Okay, Fibonacci of 8 is going to be the sum of Fibonacci of 7 plus Fibonacci of 6. Well, what's the Fibonacci of 7?
8.
8, and Fibonacci of 6 is
5.
5. So 8 plus Fibonacci of 7 plus Fibonacci of 6, 8 plus 5.
13.
You're gonna get 13, right? And it goes on like this. So that's the pattern. Fibonacci of, but the Fibonacci of 1 and 2 are already, are set. It's gonna be 0 and 1. And after that, we can determine the rest of the pattern for like infinite number of numbers. Does that make sense?
Yeah.
And hate to get all mathy, like mathematical and stuff, but this is actually a common algorithm that they ask in interviews. So I just really wanted to, we all wanted to really cover this for you guys. But don't worry, you're going to be creating your own Fibonacci algorithm when we get to Python. We're going to have a whole week of recursion. This Web Fundamentals week, we're just doing predicting the output. So I have already created a recursive Fibonacci function. So now let's cover what recursive is. So I created a function that I can, if I wanted to figure out the Fibonacci of, I'm going to console.log it though, so it prints onto a terminal. Does everyone know what console.log does?
You can explain it. That'd be cool. I mean, I think I understand, but I'd rather know like the specific version, if that's okay.
Okay, so console.log just prints the output to the terminal. So if I were to just console.log hello, right? And if I were to run this file, and you guys are gonna learn how to run JavaScript files this week now. Now we're gonna cover the JavaScript fundamentals, but I'm gonna need something called Node. In the learning platform, it's gonna explain how to download Node, and then I just type in Node and then the name of my file, which is Fibonacci.js. And it's gonna run that JavaScript. Right? If I console.log something, it prints onto the terminal. This is the terminal, this white screen that I have.
All right.
Okay?
Mm-hmm.
So if I were to console.log, fib is this function, right? And if I wanted to figure out Fibonacci of, for example, 8, it's going to give me the value for that Fibonacci of 8. This function will. Okay?
Okay.
So what is Fibonacci of 8? Well, Fibonacci of 8 is 13, right? So it should give us 13. Let's see. Okay, it gives us the number. So we created a function that's gonna, so we don't have to. You see how manually we had to figure out the numbers for each Fibonacci value or Fibonacci number.
Mm-hmm.
This function will do that calculation for us. But this function, the way it does it is it does it recursively, and recursive means it's a function that can either return a value in the simplest case. Or if this in the simplest cases are Fibonacci of Fibonacci of 1 and 2. So if n equals to 1, it's going to return 0. So if n equals to 1, right here, it's going to return 0. And if n equals to 2, it's going to return 1. And those are our simplest cases. So it knows exactly what to return. Else if n equals to 2, then it's going to return 1. Okay, does this part make sense? Just the if and else if part?
Yep.
Okay, cool. So now in the last case, so actually these first two cases are called the base cases in recursion. The base cases are the simplest cases where the the answer is like easily determined without having to do much calculations. Because for Fibonacci, answer is easily determined for 1 and 2 just by saying Fibonacci of 1 is 0, Fibonacci of 2 is 1. But then for all these other ones, we had to do some calculations, right?
Mm-hmm.
So that's what this else is doing. This is the recursive part of this recursive function. So recursive function has the base case and a recursive case. And in the recursive case, it says, well, if we're not trying to figure out the Fibonacci of 1 or the Fibonacci of 2, we're going to have to do some calculations. So it's going to return the function itself. It's going to call the function itself to try to help do the calculation. So let's break this down for a second, and then I'm going to have you guys T-diagram it out, on your own for like 30 minutes. So Fibonacci, let's look at this. Put this on Python Tutor. Okay, and then I'm gonna have it say fib of, let's say 4. Okay, I'll do something, and then visualize execution. So okay, let's go through these steps. So what is fib? Fib is some function, right? Fib is a function, and it's gonna run this. From lines 1 through 11, we just define the function. So nothing happens if we just define the function. So we're just writing some instructions for it. And now we're gonna tell those now we're gonna use those instructions to do something. We're gonna say, hey, use those instructions for the function fib, right? That's what I name my function, fib. And give it the number 4. Try to figure out the Fibonacci of number 4. That's what we're telling the computer. And it's gonna go here. And what is n, by the way? 4, right? So we're trying to figure out the Fibonacci of 4. So Fibonacci of 1 is 0. Fibonacci of 2 is 1. Fibonacci of 3 is 1. Fibonacci of 4 is 2. So it should give us 2 eventually. Okay?
Mm.
So, but we're telling it, hey, figure out the Fibonacci of 4. So is this if statement going to hit? It says if n is equal to 1, it's going to return 0.
No.
No, it's not, right? Because n is 4. So 4 does not equal to 1. So it's not going to hit the if statement. The if statement only runs if this condition inside the parentheses is true. Okay? And then else if. Else if is also another kind of check. It's basically saying if that first if statement was false, check this condition. Well, it's going to check this condition. Is n equal to 2?
No.
No.
Nope. Awesome. So then we're not going to run that part. It's not going to return 1. Now else, it's going to hit this. Else means if none of these conditionals before it were true, then just run the else, basically. So it's going to run the else condition, and it's going to run the code inside of it. It's going to return Fibonacci of n minus 2 plus Fibonacci of n minus 1. Okay. So Fibonacci of n minus 2, that's going to be, well, what is n? N is 4, right?
Right.
So it's going to return Fibonacci of 4 minus 2. What is 4 minus 2?
2.
2. So Fibonacci of 2 plus Fibonacci of 4 minus 1, which is 3, right?
Right.
So now it's going to run these functions again and try to figure out the value from these function calls right here. So Fibonacci of 4 minus 2, that's 2, right? So basically Fibonacci of 2. So it's going to do Fibonacci of 2.
Right.
Fib of 2 plus fib of 3. Does that make sense?
Mm-hmm.
Okay, so it's that's what it returns. But when it returns a function call, it's going to evaluate the function first. Because you see we're calling a function here.
Mm-hmm.
So it's going to evaluate this first, and then it's going to add it to this evaluation of this. So what is Fibonacci of n minus 2, 4 minus 2, Fibonacci of 2? Now it's going to run this function again. So if I press next, so it's going to run Fibonacci with where n is equal to 2. Okay?
Mm-hmm.
Well, it's not going to hit that first if statement because n is not equal to 1, so it's not going to hit that. Else if n equals to 2, is this going to hit?
No. Oh, wait, yes, yeah.
Yeah, it is, right? So what would this return?
1.
1. So this evaluates to what?
1.
Awesome. Yep, this evaluates to 1. Okay, now it's gonna go back here, right? So it's gonna go back to the original function call where Fibonacci of n of 4, and say, okay, I found out what to return for this first section. But we're not returning just this though. We're returning this plus this function call, which is Fibonacci of n minus 1. So we just figured out that Fibonacci of n minus 2 gave us 1, right?
Mm.
Now we got to figure out what Fibonacci of n minus 1 gives us. So n minus 1, what is n was 4, right? Originally, 4 minus 1 is 3. So we're gonna do Fibonacci with the number 3, and we're gonna run that function.
Mm.
Okay.
Mm.
So you see how it's like recursively doing things? It's like calling the function over and over again. So if n is equal to 1, is n equal to 1 now?
No.
No. What is n equal to?
3.
3. Yep. Cool. So it's not gonna hit the if statement. It's not gonna hit the else if because n is not equal to 2, right? Now it's gonna hit the else. So for this function call right here, for Fibonacci of 3, well, for Fibonacci of 2, we determined that it automatically went to that else if statement where it became 1, right? But for Fibonacci of 3, it didn't hit the if statement because Fibonacci of 3 is not equal to 1 and 3 is not equal to 2. It's gonna hit the else, and that's gonna return Fibonacci of n minus 2 and Fibonacci of n minus 1. Okay. So Fibonacci of 3 minus 2.
1. Or, well,
Fibonacci of 3 minus 2. Yep, exactly. That's gonna be evaluated to 1 plus fib of 3 minus 1. Right? Fibonacci of 3 minus 2 and Fibonacci of 3 minus 1. You guys with me so far?
yep.
Okay, cool. So Fibonacci of 3, now that returns some other function calls too. So we got to evaluate that further. So now this is the pattern in recursion. Now it's like going to evaluate this. What's Fibonacci of 3 minus 2? Well, 3 minus 2 is going to be 1. And what's Fibonacci of 3 minus 1? Fibonacci of 3 minus 1 is
2.
2. Okay, so now we got to evaluate Fibonacci of 1 and Fibonacci of 2. So Fibonacci of 1, what would that give us?
0.
0. And Fibonacci of 2?
1.
Gives us 1. Okay, so Fibonacci of 1 gives us 0. And Fibonacci of 2 gives us 1. And we said to sum those two things up. So it's like boom and boom, right? And then remember this, we said sum up Fibonacci of 2 plus Fibonacci of 3. Well, Fibonacci of 2 was 1, and it's 1 plus whatever Fibonacci of 3 is. And what was Fibonacci of 3? Well, it was Fibonacci of 1 plus Fibonacci of 2. So it basically adds 1 plus 0 plus 1. And that gives us 2. And Fibonacci of 2, well, not 2. Fibonacci of
the value of 4, yeah.
Yeah, Fibonacci of 4. 1, 2, 3, 4. Wait, it should have given us 4. Fibonacci of 3 gives us Fibonacci of 1 plus Fibonacci of 2. Fibonacci of 4 gives us Fibonacci of 2 plus Fibonacci of 3.
That's right. I mean, it should be returning 2.
Yeah, that's what I thought it was going to come.
Oh yeah. My bad. I was looking like this. Okay, yeah. It is lined up. 4 to 2. Yeah. Okay, cool. This is not perfectly aligned. Sometimes, kind of annoying. Okay, but yeah. So you see how that kind of works. The function continues to like break it down into smaller steps. The recursive step, what it does is it calls the function again to take and gives it an input that is one step closer to the base cases. So I know it's a little confusing at first, but right now we're just kind of predicting the output. So like as we're going through this, that's kind of how it's working. So I want to give you guys this code and say maybe try to do Fibonacci of like something greater, like Fibonacci of 5 or Fibonacci of 6, okay? Or maybe Fibonacci of 10 if you really have that time. But if you do something like Fibonacci of 10, it might take a long time to like T diagram. But for the function, it takes no time because computers are fast. I could do Fibonacci of 25. Let's see what that is. This number. So that function, is created to do things fast for us. That's why computers are, and that's why programs are awesome. So I'm gonna send you guys this file, and I'm gonna ask if you guys have any questions regarding recursion. Just like in terms of the flow of information. For now, you don't have to be able to come up with the solution off the top of your head, right? For now, we just want you to understand how the computer reads this function, this type of function, a recursive function.
Okay.
Awesome, cool. I'm gonna send you guys this file on Mattermost, and you can copy and paste it into. Actually, I'm gonna just send you guys the code, and then you can just make sure you call the function with some number. Just this part, I'm not sending you this part. This part is up to you. You can say fib of whatever number you want, and you can kind of go to visualize Python tutor and have a T diagram on a piece of paper and try to predict the output as it's going through its process, or just try to visualize the flow of information, just to train your brain to think like a computer. Okay. And for these 2 days, by the way, for this JavaScript introduction for today and tomorrow, it's going to be a lot of fundamentals of JavaScript syntax, and you guys are going to be building out your own algorithms, not difficult ones like these, but it's going to start with something simple, and it's going to start getting more difficult. So these first 2 days might be kind of like, I would say you're not really building any cool web pages or anything. But then after that, after you get the JavaScript syntax and fundamentals down, we're going to introduce jQuery so that you can do some cool stuff with JavaScript on your HTML and CSS. Okay?
Cool.
Awesome. So I'm going to send you guys this on Mattermost. So look out in Mattermost for that. So run that. But make sure after you run it, not run it. Before you run it, make sure you call the function fib and then give it some number to run and then visualize the output, okay? And I'll see you guys at 9:45.
Okie dokie.